Welcome to the TOA CX-1000 online training. This time we will have a closer look at the provided surveillance features of the system. First of all, this webinar is based on firmware and software version 1.1.0. If you're watching this webinar sometime later, it might be that some features have been improved or added. Let's start with the technical background. The system surveillance leads to an indication that a certain device or component of the device is not functioning properly. All faults can be indicated at central points, audible and visible. One option is the System Manager CX-1000. You get a status LED, a fault acknowledge and fault reset key, and a fault buzzer. Another option are the display stations like CX-OP1700 and CX-RM1700. In the display, you can get, for example, a general fault message or more detailed descriptions for specific devices. If the faulty device is not entirely out of order, it can also indicate its own malfunction via an LED. And the fault indication is not limited to the CX devices, it can also be forwarded to external systems. Let's have a closer look at the specific monitoring features. First of all, we have our LAN connection. If a device is equipped with two LAN connectors, then each connector can be monitored separately. Then we have composition. This ensures that the setting data saved on the individual devices is matching the data on the system manager. For the intercom stations, it can be checked if the physical keys are stuck and therefore not operational. Looking specifically at the call stations, the system can remotely press the call key to check the general operability. Of course, this check will not actually trigger a call. Then we have the checkpoint internal. This includes abnormalities of the power supply voltage and the CPU temperature. Again, for the intercom stations, the hands-free microphone and speaker audio line can be checked. A surveillance tone will be played back at the speaker and recorded by the microphone to check if everything in the audio line is working properly. We can also monitor the amplifier of the zone amplifiers. And finally, if we have an integration of a file server to store log data and audio recordings, for example, the server accessibility can be checked. Why do we need system surveillance? Imagine you are in hospital. You need some assistance and want to use the call station of your room. But the call station is not working. You know about the problem, but no one else in the entire building knows about it. This can be inconvenient in some occasions and dangerous in others. Or imagine a situation at school. Someone got injured or a fight between two students gets out of hand. You try to call the secretariat, but nothing is working. Because the connection between the station and the rest of the system is interrupted for some reason. Then you have to search for a person nearby or, in worst case, have to go to the secretariat by foot, and this will cost you a lot of time. Another situation can be a parking lot that uses video intercom for manual access control. Imagine that some parts of the system are not working properly. People try to enter the parking lot, but the person responsible for the access control does not receive any calls. This can lead to many people not being able to get to work, which will cost the company a lot of money. But with a working system surveillance, you can detect faults early and provide fixes as soon as possible to ensure that the system is ready when it is needed. Using CX-1000, what is possible and what is not? We have components that are monitored permanently, meaning in less than a minute you will get a fault indication. This includes the network connection, the composition, meaning setting mismatches, stuck keys, and we have the internal category. Additionally, there's a scheduled self-check every 24 hours. This includes the audio line of the intercom stations, the overall checkup of the call buttons of the wall stations, and the connection to the file server. This self-check can also be performed manually at any given time at the display stations of the system. Furthermore, since it's possible to integrate other systems into CX-1000, it's possible to forward fault information from another system to CX-1000 via external fault inputs. On the other hand, the surveillance is not possible for ZIP telephones, for on-with cameras and IP speakers, because those devices are integrated via open protocols that do not allow system surveillance. Also important to know is that there is no speaker line surveillance for the power amplifiers. The checking of the amplifier itself is the only check that is exclusive to the manual self-check. This was the theoretical part. Now we come to a practical example. Connected to our network switch, we have of course our CX-1000 system manager, because this device is required for every CX installation. Then we have our operation station CX-1700. This device will be used for intercom conversations with the call station CX-1050. Additionally, we have the power amplifier CX-P81240. How does the setup in the settings software look like? First of all, we go to Failure Detection and click on Checkpoint. Here we can see an overview of all components and features that can be monitored. We can select all checkpoints at once, deselect all at once, select every checkpoint individually, or select all for an entire device. In our example, we do not have redundant network connection, and therefore we remove the surveillance of LAN port B. This will lead to a prompt telling us that removing a specific checkpoint will also remove this checkpoint from surveillance patterns. We will have a closer look at those patterns soon, but be advised, if you deactivate a checkpoint and reactivate it afterwards, then you will have to redo some of the following steps. Since we also do not have a file server in our setup, we will also remove the surveillance of the connection to the server. Next, we go to Self-Check and make sure that the scheduled self-check is activated. This self-check will be performed at a specific time each day, and you can change this time via various input methods. If you have activated the hub function, which separates the system into several subsystems, this window looks a little bit different. You can activate and deactivate the scheduled self-check and also change the time of the check for every hub individually. Now we want to take care of the analog control connections to external systems. First of all, we want to integrate an external failure input. We go to Event Activation, Control Input, and select, for example, our amplifier. Imagine we have a backup power supply that can trigger a fault output if it has a failure. We rename the control input for visibility reasons and select the external failure input. In our example, we leave it on normally open. And now we want to take care of the control output to other systems. We go to Basic Operation and Control Output Group. We rename our group, in this case Warning Light, because we want to trigger a warning light if any of the CX components or the backup power supply have a failure. And we want to connect the warning light to the first control output of our system manager. Next, we go to Failure Detection Output Pattern and create a general fault pattern. With one click, we can select all or deselect all checkpoints of all components in the system. For our general fault, we select all. Then we go to Control Input and select the external failure input at our amplifier. And finally, we select our Control Output group. Now we create a second pattern only for our call station. In this case, we only select the checkpoints of our CL1550. And we do the same again for our amplifier. The next step is making these features available at our operation station. We go to Event Activation and Key, select our operation station, rename of course the keys for visibility reasons, and select Failure Acceptance. Because this key is for our call station, we select the appropriate failure detection pattern. And we do the same for our amplifier. If you assign a failure acceptance key to an operation station, the station will react to faults of the components included in the pattern. And our third key will be the failure reset key. This key will reset the failure status for the entire system. If you are using the hub function, you can decide if the failure reset key shall reset the failure status for the entire system or only the hub that the station belongs to. There is a specialty that you will come across when using more than 31 devices in your system. Just for demonstration purposes, let's add 40 OP1700. Now you can see under Failure Detection, a new setting called Failure Detection Leader appears. The system will be automatically divided into groups consisting of a maximum of 31 devices each, and each group requires a failure detection leader. If this leader is disconnected, the failure detection of the entire group will not be working properly. By default, the selection of this leader is set to automatic setting. But you can also select the leader for each group manually. Important to know, the control interface CX-1000 cannot be selected as a failure detection leader. And if you're using the hub function, each hub will have its separate set of failure detection groups. And for each hub, you can decide if you want to use the automatic or the manual selection of the detection leader. But please remember, since the CC1016 cannot be selected as a failure detection leader, a hub consisting of only a CC1016 cannot provide failure detection. This shall be it for the programming side. Let's have a look at the user operation at the hardware. If there are no faults in the system, our devices look like this. The operation station OP1700 is displaying the 3 keys that we have created before. At the System Manager, the power, run and status LED are lit constantly, while the LED for LAN A is blinking. Looking at our call station, we have a run and status LED that are also constantly lit. But now we remove the network connection. And in this case, this is also the power supply of the station. The System Manager will display all faults that are included in any failure pattern. Therefore, if we disconnect the station, the status LED will start blinking and turn yellow, and the buzzer will start to sound. Looking at the operation station, we will get a pop-up combined with buzzer sounds. The displayed failure detection pattern is the one that we created especially for the call station. Of course, the names of the output patterns can be changed according to the project's requirements. If we press Acknowledge, the buzzer sounds will stop, but we still get an indication that our call station has a fault. And by creating multiple keys for multiple types of faults, you can get a clearer idea of where to find faults in the system by simply looking at your operation station. Alternatively, you can press the Fault Acknowledge key at the System Manager. The buzzer sounds will stop and the yellow status LED will be constantly lit. You don't have to acknowledge the fault at every single device. Pressing it at the System Manager or the operation station will acknowledge the fault for the entire system. The Fault Acknowledge function can also be assigned to control inputs of any device. Same for the Failure Reset function at the OP1700 or the System Manager. This key entirely removes the fault status of the system. But be advised, if the fault still persists, the failure will of course be detected again. If we reconnect our station and wait for it to be booted up again, the system will detect this, and after a while, the fault status will be reset automatically. Now we want to do the manual self-check at the operation station. We go to the Device menu, select Maintenance, Self-check, and now we select the hands-free speaker and microphone, the call button and the amplifier. We leave out the external storage because we do not have a file server in our system. At the end, we press Start and wait for the check to be carried out. Afterwards, you can see the results. If you want to display the faults but do not want to hear the fault buzzer, you can go to the Device menu, select Settings, LCD Failure Buzzer, and there you can disable it. At the System Manager, this can be done via dip switch. Looking into the web interface of the System Manager, you will find a failure indication bar at the bottom of the window. If there's any fault in the system, the failure icon will turn yellow, and clicking on Check will lead you directly to the system status. Here you can check the status of every single device. Devices with detected failures will be marked with an exclamation mark. And clicking on the device will provide you with detailed failure information. Clicking the Check button will automatically acknowledge the fault for the entire system. And the web interface also provides the possibility to reset the failure status. If you have a more complex situation and try to figure out why certain faults occurred, it is recommended to have a look into the system log. The operation log shows the last 100,000 events that occurred in the system. This includes normal events like conversation start and stop, and also failure events. And if the log is full, old entries will be overwritten. You can search for specific events using filter functions. You can display the events of specific devices and also limit the time frame. If you're using the hub function, you can also display the events of a single hub. You can choose if the event list you're currently looking at is updated automatically or not. And of course, you can download the entire list of events. If you're looking specifically for failure information, it is recommended to have a look into the failure log. Here you have the same filter options as in the operation log. The failure log is limited to 10,000 events. Additional information can be gathered via the stream log. For each device you can download a TXT file that lists the entire communication with other devices in the system. The stream log is also limited to 10,000 events for each device. Let's have a look into the maintenance view of the web interface. If you click on Self-Check and go to Scheduled Self-Check, you can activate and deactivate the Scheduled Self-Check like in the settings software. And if you go to Manual Self-Check, you can do the same manual self-check that you can do at the operation stations. And you can start and stop the self-check for each hub individually, if you are using the hub function. And this shall be it for this webinar. Thanks for watching and see you next time.